Hello class, welcome to Unit 7 Video 6. Today we're going to be analyzing graphs of polynomial functions. You're going to want to have a graphing calculator with for today because we're going to be graphing those polynomial functions on our calculator and then analyzing them. And as part of the graphing, we are going to locate their real zeros, their max, and their minimums. Okay, so you're going to want that graphing calculator. So we have an example here. It says the percent of U.S. population that was foreign-born since 1900 can be modeled by P of t, which is a polynomial equation. Where t equals 0 in 1900, notice that the graph is decreasing from t equals 5, which is approximately here, to t equals 75, which is here. And then it begins to increase. The points at t equals 5 and the points at t equals 75 are turning points in the graph. Okay, so turning points are our highs and our lows, and it's when you go from a this one goes from increasing, if you were to graph all the polynomial, increasing to decreasing or decreasing to increasing. One thing to note, and we have talked about this before, is to find the degree of a polynomial. It's your number of turns plus 1. So for this one, let's look. I have 2 turns. 2 plus 1 means my degree would be 3. Well, if I look, is my degree 3 of this? Yes, it is. So those are my turning points. My turning points are also called maximum and minimums. Okay, this is a max because it's the highest. Okay, and this one is a min. So those are some other values we are going to be looking at today. We will be finding the real zeros of a function, the relative max and the relative min. Okay, so just to recap, real zeros of a function. The x value is where a function crosses the x-axis. Okay, so it's wherever it touches that x-axis. We've also found these before. They're called zeros. We've also called them roots, solutions, x-intercepts. And you can always find the real zeros. It's when y equals 0. Okay, the other thing we're going to be finding is a relative maximum. Okay, it's a point where the graph changes from increasing to decreasing, and no other points around it are higher. So I'm just going to sketch a little picture here. Let's say I have this polynomial. Okay, so a relative max where I go from increasing to decreasing. So looking here, I'm increasing and then I'm decreasing. So this would be a max and this would be a max. They're both relative maximums because no other points around them are highest. See how it's the highest point in this area? So it's a relative maximum. Same thing with a relative minimum, except for now we're going from decreasing to increasing. So if I look back at my polynomial I drew down below, increasing to decreasing. Now I'm decreasing, I'm going to increasing. So this one is a relative min. They say relative because obviously if I ask you for the maximum point, it is this point right here. Okay, but if I'm asking for the relative max, it means it looks like a high point for what's next to it. Okay, and another reminder is the relative max and relative min are also called turning points. So how many turning points do I have here? There's 3 turning points. So 3 plus 1 is 4, so we could probably guess that this is a 4th degree polynomial. Just something to note. So that means I would have an x to the 4th for this one. And since both my arrows are going down, it'd probably be negative x to the 4th. Looking at example 1, it says graph the polynomial f of x equals x to the 4th plus x to the 3rd minus 4x squared minus 4x by making a table of values, describing the end behavior, and determining the number of real zeros the graph contains. Okay, so I'm going to use my calculator. If you don't have a graphing calculator, you literally need to take negative 2.5, plug it into this, get your answer. Okay, so we're going to do that. So I am looking at this and I am plugging in negative 2.5. So I would have to do parentheses, negative 2.5, and parentheses to the 4th, minus parentheses, negative 2.5 and parentheses to the 3rd, minus 4 parentheses negative 2.5 to the 2nd, and then minus 4 times x, which is our negative 2.5. Okay, and we would get that our answer, did I miss something up when I typed it in? Negative 2.5 to the fourth. Oh, right here. This should be a plus, right? So I'm going to arrow up. Hopefully you caught that. Plus with my x to the third. Almost there. Okay, there it is, 8.4375. So I get my first ordered pair. I'm just going to say it's approximately 8.4. Okay, then if I wanted to get the next one, I would do the same thing. Okay, but here's the nice thing. With my graphing calculator, I can literally put this into my calculator and get out my answers. So what I'm going to do is go to y equals. You're going to want to know how to do this. Okay, so make sure you're paying attention doing it on your calculator. And you enter in the original equation. It is x to the fourth plus x to the third. And make sure if you have one that you have it flashing up in the exponent, you arrow to get down. And look at mine didn't put the x in. Okay, x to the third minus 4x squared minus 4x. All right, so it's typed in. I'm going to confirm I typed everything in correctly. Looks good, okay? So now I want to get my table of values. There's a table on your calculator, okay? So what I'm going to do is there's table set, which is listed right above your window. So second, table set. We want our table to start at negative 2.5. And then the delta table is what I want it to count by. Look I want it to go by 0.5. So not at 1, but 0.5. Okay. Now what I need to do is see how table is above graph. So second, table. And all of my values are listed for me. I got this one. This one is, it looks like 0, 1, negative 1.3. Okay, so let's go ahead and put those in here. Okay, so I'm going to recopy these down. Make sure you recopy them as well. And you can just do the estimated. See how this can be much quicker than your calculator. Than just plugging it in. So having that graphing calculator is nice. All right, now that I have this table of values, and hopefully you copied yours down, I'm going to go ahead and do my best putting those on here. So I have negative 2.5 and 8.4. Well, that's not going to fit on there, so I'm not going to put it right now. But I do know it's way up here somewhere. Okay, now I'm going to do negative 2, 0. Negative 1.5, negative 1.3. Negative 1, 0. Negative 0.5, 0.9, 0, 0. Negative 2.5, negative 2.8. 1, negative 6. 1, 2, 3, 4, 5, 6. 1.5, 6.6. And 2, 0. Okay, now looks a little crazy, but I'm just going to connect it. Just go in order. Connect the dots. Going down and all the way back up. So here is a rough sketch of my polynomial using my table of values. Okay. Now what I need to do is answer the question. So we graphed it. Now we need to describe the end behavior. Okay, my end behavior. Sometimes they write it the opposite. So let's just try that. Let's do as f of x goes to blank, my x, sorry, it's not as, it's f of x goes to blank as x goes to infinity. Okay, so looking to the right, what's happening to my y values? They are going up, so that one is going to infinity. Now we're going to say f of x, what happens to it as x goes to negative infinity. So it's time negative infinity, looking to the left, what's happening to my y values? They're going all the way up to infinity. Okay, so this here is my end behavior. Okay, now we have to determine the number of real zeros. Okay, real zeros, there are 1, 2, 3, and 4. So there are 4 real zeros. Okay, and let's just say what they are, because these ones are actually really easy to see. They're actually listed right here in our table. It's where y is 0. So x equals -2, -1, 0, and 2. Those are where my real zeros are. Okay, so that is example 1. So look at how handy that graphing calculator can be. Let's move on to example 2. Okay, this one says sketch the graph that we're given on the coordinate plane provided. Determine the consecutive integer values of x between which each real zero and the function is located. Then estimate the x coordinate at which the relative max and minima occur. Okay, so first thing we got to do is graph it. So let's go ahead and grab our calculators and let's plug this one in. So we go to y equals first. Okay, we already used this function. We don't need it anymore, so we're going to clear it out. So clear, and now I'm going to type it in again. X to the third, arrow over, -5x to the second, plus 3x plus 2. Okay. This one, I would look at it and say, I need to do my table of values, and I would say that these are probably going to count. We can do them by 0.5s again, so maybe let's just do, I don't know, let's look at the graph. Maybe that'll give us a better idea. So hit graph, and you can see what it should look like. Okay, well, this is -1, and then this is 1, 2, 3, 4. So let's do like a table maybe from like -1 to 4.5. So I'm going to go to my table set. My table set, -1, and I'm going to count by 0.5s again. Okay. So then I go to my table, which is above graph, so second table. Here's my value. So I have -1, -7. Okay. -0.5, -8.75, 0, 2. Okay. I have all these points. I'm going to go ahead and plot them. Okay. You should as well. So I have -1, -7. -0.5, -8.75, 0, 2, 0.5, 2.375, one is 1, 1.5 is -1.375. I'm just going to keep plotting them. -2, -4, 2.5, -6.125. 3 is -7. 4 is 3.5 is -5.875. 4 is -2. And I kind of want to do what 4.5 is, or know what 4.5 is, so I'm just going to go here. And if you want to find more values on your table, you can just arrow up and down. So this tells me that 4.5 is 5.375. Okay, so way up here somewhere. Then once again, we go ahead and connect our dots. Okay, so looking at this, I have zeros. I need to find my zeros. There's one here, here, and here. So if you did not have a graphing calculator, you could say there are zeros between 0, and -1. And there's 1 in between, let's see, 1 and 2. And there's 1, so 1, 2, 3, 4, and 5, in between 4 and 5. Okay, that's all nice to do, but I actually prefer that if you can and you have a graphing calculator handy, let's actually find those 0 values. So I want to figure out what x equals for all of them. So I go ahead and I pull up my calculator and I'm going to go to the graph of it. So hit graph. And I want to find the zeros. There's one right here, and right here. So in order to find that, you go second, calc. Okay, we want to find the 0, which is number 2. Notice how it says left bound. Okay, if I want to find this point, I have to be to the left of it. So I'm going to move my little cursor over so it's to the left. It's currently to the left, so I would hit enter. Then I move it to the right of the point and hit enter, and then I hit enter again. This tells me my 0 is -0.391. Okay, there's my first one. Now I move on to my next one. I go second, calc again. We're finding that 0, number 2. If I want to find this one, I need to be to the left of it. I'm going to move a little closer. So I hit enter, and then I'm going to move to the right of it. So I did the left, now I'm doing the right. And then for guess, you can just hit enter one more time. So my 0, it's when y is 0, so my x is 1.227. So that's my other 0. Okay, and to find my last one, I go second, calc again. 0 is number 2, and to be to the left at this point, I'm going to move a little closer to it. Okay, I'm to the left of it, so I'm going to hit enter, and now to be to the right. See how this got little arrows telling me to go to the right as well. Okay, and guess, and my last 0 is 4.164. Then I can validate that these answers are correct. Okay, I really recommend that you try and find these on a calculator because you're going to need to do it in the future. Okay, the next thing we're going to do is find our maximums. We could estimate what this is and this is, but I would highly recommend, once again, just finding those on your calculator. Just to clarify, my max is this point, and my min is this point. Okay, even though we're going higher here, according to this area here, this is my lowest point. Okay, so those are my max and my min. So I'm going to go back to my calculator, and you could estimate and say, oh, this one looks, you know, close to 0, and this one looks close to 1, 2, 3. But let's actually find them on our calculator to be certain. So if I want to find my max, I go to calc again. So second, trace, which is calc is above it. We're finding the max, which is number 4. Now to do the same thing, it says left bound. Here's my max, so I have to be over here to be to the left of it. So I got to move over. Where's my little flashy cursor? All right, to the left. I am to the left, so hit enter. Now we're moving to the right, hit enter, and my guess, enter again. Okay, my max is 0.3333447. So it's not exactly 0. So my max is actually at, I'm going to say, 0.3 repeating is 1/3, so my max is at x equals 1/3. Let's find my min. It looks like it's at 3, but you never know. It's not, our picture is not drawn accurately. So we're going to go second calc again. To find the minimum, we hit 3, and I have to be to the left of this point. Currently I am. I'm just going to move a little closer. Okay, enter, and then I'm going to move to the right of that point. Enter, enter, and my minimum is 2.9999997. So really what it's trying to say is it is at 3. So that one really is. Okay, so that is example 2. Let's move on to example 3. Okay, same thing, sketch it, find the zeros, find the max, find the min. Okay, so we go to our y equals, clear it out. I plug in x to the 4th minus 9x to the 3rd. Oops, forgot to move down. Plus 25x to the 2nd plus 24x plus 6. Okay, to graph it, I would go to my table of values, and I would look at the way this one's labeled. Notice how it's actually counting by every 2. So I'm going to change my table set for this one. First, maybe let's look at the graph. Okay, so it's only showing the part of the graph. I can see it here, so I'm probably going to need to change my window. Maybe did I put something in wrong here? X to the 4th minus 9x to the 3rd plus 25x squared. Oh, right here, minus 24x. So hopefully, once again, got to be careful in typing things in. Okay, minus, let's do that, and then let's graph it and see if that makes a difference. Sometimes you might have to change your window settings, so be aware of that. Okay, so there, perfect, it shows up. So if you look at this one, I would maybe try and figure out what my point is at -1. Or yeah, so let's start our table at -1. And then like I was saying before, this is actually going by 2s, so let's not count by 0.5s for this one. So let's start at -1. And let's just count by 1s. So I would say 1. And then let's look at my table and let's plot those points. So I have -165. So that one is really going up there. Then I would have 0, 6. Then I have 1, -1. So be careful when you're plotting it because it counts by 2s. 2, 2, 3, -3, 4, -10, 5, 11 up here. Then it goes 6, a really big number, and then we just keep getting really big numbers. All right, so I knew I was coming from some big number here at -1, coming down, connecting the dots, going down. Okay, mine's really bad looking, but I hope yours is a little better than mine. So it goes down, up, and around. So let's just look at the graph again. Okay, slowly but surely. Okay, so how many zeros do I have? It looks like 1, 2, 3, 4, and if I look here, it looks the same. So let's find all of them on our calculator. Remember, if you have to plug everything individually with your calculator on your table, then you're going to have to just say, well, it looks like it's between, this one looks like it's between 0 and 1. Okay, this one looks like it's in between 2 and 3, that type of deal. But we're going to find them on our calculator. So second calc, 0, number 2. So let's start with this one. To be the left of it, looks like I am. And then I'm going to move to the right using these keys. Enter my guess. So x is equal to 0.382, rounding to 3 decimal places. Okay, there's 1. Let's find the next one. So second calc, 0, number 2. Trying to find this one, so I'm going to move a little bit. Okay, I'm to the left of it, going above. I'm to the right. So x is 1.51. So that's my next one. 515. Let's find the next one. So second calc. Hopefully by the end of this, you're pretty good at finding these on your calculator. Enter, going to the right. Enter and enter. And then we got x is equal to 2.618. And let's find the last one. So second calc, my zeros. Got to move to the left of it. And then we got to be to the right of it. And so we got 4.732. All right, now let's find our max and our mins. Well, looking at this one, this is a relative max right here. And these are my relative mins here. Okay, so let's find the max first. So second calc, max is number 4, so I need to be to the left of it. So right now I'm here, I got to move all the way over to that point. Enter, going to the right, enter, enter again, and our max And if you wanted to, you could write the ordered pairs. It's only asking for the x coordinate, but really your max is at 2.000. They're really trying to say 2, 2. But all you need to write is x is equal to 2. Then my minimums, let's go ahead and find those. So second calc again, minimums are number 3. So let's find this minimum. So right now I'm to the right of it, so let's move to the left. Okay, I'm to the left, moving to the right, I guess. And it's delayed. But when you guess, you should get that x is equal to 0.75, and your ordered pair for this one is 0.75, negative 1.418. Okay, my calculator seems to be freezing at the moment, not working. Okay, then you would do the same process to find this minimum. When you do that, and I recommend you check to make sure I did it right when I did it on mine, but you should get x is equal to 4, and that would give us the ordered pair for negative 10. Okay. So let's go ahead and look at our last example. The average fuel in gallons consumed by the individual vehicles in the United States from 1960 to 2000 is modeled by the cubic equation given here, where t is the number of years since 1960. Okay, it says sketch a graph of the equation. Okay, you would do the same thing going on your table to get this, but let's just do it. At 0, if I plug in 0, you can all see I should get 645. Sorry, 654. Okay, if you plug in 10, you should get 711.5. If you plug in 20, you should get 619. When you plug in 30, you should get 526.5. And lastly, when you plug in 40, you should get 584. 584 for this point. So if I connect them, and you could do this very easily on your calculator like I've already showed you, there is my graph. It says determine the turning points and end behavior of the graph. Okay, well, the turning points are right here. Okay, so my turning point, and I would find them specifically on yours, are when x is equal to 711. Sorry, when x is equal to, if you find the max, because remember this is just a sketch, using your calculator, let's see if mine is working. Nope, still not working. Okay, using your calculator, and I would recommend that you would, you should find that the max is when x is equal to 7.483, and you should find that your min is when x is equal to 32.517. Okay, those are our turning points. Now let's determine the end behavior. Okay, now I'm going to write it the opposite way as I did before. So now I'm going to say as x goes to infinity, f of x. So as I go to the right, what's happening to my y values? They are going up. So they're going to infinity. And as x goes to negative infinity, if we look to the left, if the trend were to keep going, this would keep going down. So I'm going to negative infinity. So there's my end behavior. Okay. C says, what trends in fuel consumption does the graph suggest? Is it reasonable to assume that the trend will continue indefinitely? So we're looking at this. This is saying if the trend continues, gas will always increase. Do you think that's true? Well, you guys have already seen it happen. It goes up and down. It doesn't just keep increasing. So do we think that's going to continue? No. At some point, the economy is going to change. So at some point, the economy will drop. And lower the price. Okay, so it won't always continue to go up, even though sometimes we think it will. All right, that is the end of the video. I'm sorry I had a little calculator malfunction. If you have any questions on how to use your calculator, please come and ask. Otherwise, have a great day, and I'll see you later.